Greetings to one and all. In this particular video, we'll execute a practical, that is the first machine learning practical, as per the syllabus prescribed by SPPU. So, initially, we need to import the required libraries, that is pandas libraries. Pandas as PD, NumPy as NP, pandas for performing data analytics and storing the data as a data frame, NumPy, that is numerical Python for NumPy arrays, Seaborn and Matplotlib for visualization, for plotting the graphs, etc. Read the Uber dataset. Print the first 5 rows by df.head. Similarly, df.tail, what it will do? Any guesses? It will print the last 5 rows. Then we can print df.shape. That means total number of rows and total number of columns. So there are these many rows and these many columns. Then df.info. df.info will give all the column names, whether they are null or not. That means not null, how many are there, that it will tell. Then it will tell us that not null count. This is a single thing that they've written. Not null count means how many values are not null in each of the columns. Okay. And the data type of each column. That means float 64 means on 64-bit operating system, the float space, float, int, string, all these occupy certain space in memory. In 64-bit system, how much float occupies? Suppose it is 8 bytes, then that much space each of the values in each column having float data type will have. Now, instead of string, it tells us that it is an object, okay? Because sometimes strings are classes and we can create objects of those classes, right? Then df.describe is also there. Info gives us column name and how many are not null and their data type. In describe, we have to find the count. That means how many values are there in each column, the mean of all values, standard deviation of the values, minimum value in the column, maximum value in the column, 25% medium, 50% medium, 75% median will also be displayed. Now we can see that we have columns like fair amount, pickup longitude, latitude, drop off longitude, drop off latitude, and passenger count. Now, based on this data set, we need to predict that how many passengers are using these Uber services, such that we need to predict that for a given pickup point to the agreed drop-off location, what will be the price of the ride. So here we have certain sample pickup locations. So this is the pickup longitude, latitude, and drop point longitude, latitude. Means from this position to this position on the surface of the Earth, we have to find out what is the cost of this ride. So based on these training examples, we can predict the price of some new example as well. So this we can use for training. Okay. All these concepts like maximum, median, standard deviation, we have already discussed. Now df.columns will give us the name of each of the columns in this data set. Now in this data set, some column names are unnamed. So wherever the column name is absent in the CSV file, it will come as unnamed. If there are 2 unnamed columns, this is unnamed 0 column, unnamed 1 column. If this was unnamed, it would be unnamed 2 column. Okay. Now, whichever unnamed columns are there, we want to drop that. So df.drop, pass a list of all those columns which you want to drop. Okay. Along with unnamed column, there is a column called as key also. That also is not necessary for a prediction. So we are dropping it. And this column to be dropped, it has to search which columns have to be dropped and it will search it column wise. So access is equal to 1 to drop the columns which aren't required. So now finally our data set has reached to this particular state. Now we are printing df.dtypes. So we have floats, ints, and string, that is objects. And again, we can print df.info if we want to see how many are not null and so on. Now we'll describe the data set once again because we have removed certain columns. So let us see the data set once again. Okay. Now, if you want to fill the missing values are the values where the value is absent in that particular cell. So there it will be represented as NaN. Now, if we display the data set as a Boolean data set, so we need to write data set name df.isNull. Okay, so when we print this, wherever value is present, if value is present, then it will show false. If value is absent, it will show true. This is because we are asking is null. Is this null? No, false. Is this null? False. And so on. Now, if we write df.isNull.sum, then column-wise, how many null values are there? It will show. So drop of longitude and latitude have one null value each. Now, we also want to find the summation of all these values so that we get the total number of null values in the data set. So df.isNull.sum, again .sum we need to write. So total there are 2 null values in the entire data set, data frame. Now we want to fill these values. So what we usually do, wherever there is a null value, we fill it with the mean of that column. So this is the syntax. For drop of latitude column and drop of longitude column, you have to fill, calling the fill NA function. And what value you'll fill? The mean of the column. Value to be filled is what? The mean of the column. And in the original data set, it should be reflected. So n place equal to true. Now, if we check for the summation of all the null values column wise, these also have become 0. Where there was 1, it has become 0 because we have filled it with the mean. Null values usually arise due to inaccuracy in data gathering. Now, the data type of the date time column, though it is date time column, it is considering that date time to be a string. So what we have to do, it is a function within the pandas library. So pd.toDateTime, and we have to convert which column to date time? The pickup_datetime column. And if there are any errors, course them. Now, suppose in our date time column, we have some values like 18th Jan or something like that. We have the dates. But suddenly, suppose we have a floating point value, 4.6. And this we want to convert into a date time. Or maybe our date time format, instead of writing the date, we are just writing the year. Then in such cases where it is actually a value which is not possible to get converted into a date time format, we will coerce it. If we write the errors parameter equal to coerce, it means whenever the parsing or the attempt of conversion, whenever the attempt of conversion of that value to date time type is invalid, that time set that value to NaN. That value cannot be converted to date time. So set that value as NaN in that particular cell. Another value that you can give for this errors is ignore. Means if there is a invalid value, keep it like that and proceed. Or raise means if there is invalid parsing, raise an exception. Exception handling needs to be performed. Now, after converting the date time column to actually date time data type, now if you check the D types, you can see that date time column has become date time. And this UTC equal to true means whatever date time value is present in this column, it should be in UTC time zone. So UTC time zone should be true. That is what we are doing. Again, we are printing the head now. Now, what we want to do is this date time, we want to break into the hour, day, month, year. This is the date and this is the time. So date, time. So this date, we want to break into day, month, year, and from the time we can get the hour, and based on the date, we can understand that it is which day of the week. That means we can start from we are starting from suppose Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So Monday is designated as 0, as you can see here. Tuesday will be 1, Wednesday 2, Thursday is 3, 4, 5, and 6. So the day of the week and the name of the day, that also can be printed. So what we have to do, we have to create new columns using this particular syntax. We can say df of r should be df of pickup date. Now, whenever you write df dot column name, this has the data type of a series. This is a series data type. And to access the r from this, we know the date. We want to take the r, or maybe from this date time, we want to take the day or whatever we want to take. We must write dt dot r or dt dot year, month, whatever. So we are creating new columns from the already existing column by separating the column into parts. Now, syntax to do this was either this, or you can also do it this way. df.assign r equal to this, day name equal to this. So these are just differences in the syntax. The output or the outcome will be same. Intention is same. So after adding these columns, let us check for their description. So this is the description. That means how many values are there, what is the mean, standard deviation, and so on. Now, note that we had one more column, day name. But we cannot see output for that. This is because the values in the day name column are categorical. And this description is only for numerical valued columns. Okay, so only numerical valued columns are appearing over here. Now you want to find out the unique values in the particular column. Because fair, as you can see, there are so many values, and maybe from location to from A to B and A to C, the fare is same. Or maybe from B to D and E to F, distance is same, so fare is also same. So we want to find out all the unique fare amounts. That time we write dot value counts. And what this does is, whatever unique values are there, it sorts them in descending order. So if we have unique day fare amounts like these, then it will sort them into 7, 6, 5, 4. So the first unique value is the maximum of all the fares. So maximum count is x of, if we write 6.50 and we print x, we can find out that x actually holds the value counts, means that all the unique counts, first of all, it will find, arrange them in descending order, and this value, this unique fare amount, how many times it appears? Suppose 10 times the fare 7 is involved. Suppose 12 times the fare 6 is involved. Suppose 4 times this fare 4 is allowed. So first of all, sort them in descending order, and their occurrence is also displayed. So whenever this x stores this values and their occurrence. So now, if I want to find out the count of a particular fare, whatever the fare is, x of that fare will give me the count. Like this, it works. So that data of particular fare will give you the occurrence of that particular fare. I hope you are understanding. Now, once we have distributed the date time column into hour, day, month, and all, we want to eliminate that date time column itself. we got what we wanted. So now we want to eliminate. And we want to display the first 5 columns of this. And again, let's check the types. Also, we want to drop the day name. Okay, just for understanding, we displayed that, but now we don't want. Now, if you want to find out number of columns, we can find length of column. Number of columns means whatever columns we had, fair, hour, day, total number of columns we want to find out. So df.columns is a list of all the columns. Length of that list is total number of columns. Now, number of columns is 12. That means 11 quantitative and 1 categorical, which we have removed. Okay. Now, suppose let us see the data set once. Okay, so here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 columns, out of which 11 are categorical and this 11 are numerical and this one is categorical. So the number of columns is 11 because we have dropped that day name column. Now suppose we have not dropped that day name column. That means we have 12 columns, right? 11 quantitative, 1 categorical. Suppose we have not dropped it. Then what happens is, if we want to plot the box plots. Now box plots is what? It is showing the characteristics like 25% median, 50% median, maximum, minimum value and all, which is not possible for categorical values. So you drop the day name column or not. Since it is categorical, box plot will not be developed for that. Now, this is the syntax for box plot. So this is the syntax for box plot. The type of plot should be box. Subplots means for each column we need to find box plot. So subplots should be subplots in the sense, if we are doing box plot, we want separate box plot for each column, or in one graph only, we want to plot for each column. These are the box plots of each of the 11 numerical columns. Okay, these are the box plots for each of the 11 numerical columns. It is within a single graph. But if you want separate graphs for each column, that time subplots must be true. And the layout is 7,2 means you should have a grid of size 7 rows and 2 columns. The grid size should be 7 rows and 2 columns. And figure size, that means this grid should occupy the size of 15 rows and 20 columns. See here, this is the case when subplots is true. That means for each column, for fair amount, for pickup longitude, and so on, we have separate box plot as a plot. Now, this is a grid, and you can see there are 2 columns and how many rows? 7 rows. So as you can see, I was saying that there are 7 rows and 2 columns. Now, you may have observed that if I say 7 rows, here there are only 5 rows and 2 columns. This is because maximum there should be 7 rows and maximum there should be 2 columns. So we know that box plot is possible for how many columns? For 11 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have dropped one categorical column, that is the pickup time, right? Initially, we had 11 columns, which are all numerical, but we split the date time column and then we dropped it, right? So now there are 10 numerical columns. So 10 particular plots are possible. 10 plots. So 5 rows and 2 columns is sufficient. 7 rows and 2 columns is also fine. It will not give you error because whatever size you are specifying, it is more than the requirement. The required grid is of 5 rows and 2 columns, and we have given extra grid space. Okay, so this is because if we give a little more, then no problem. But suppose we give lesser, that means 4 rows and 2 columns. The number of rows is less. Requirement is 5 rows. This time it will give you error. So this is not good. This is good. And if you give exactly the required, that is also fine. No problem. Okay. Now we are going to see about the clip function, which you've already seen. That means let us generate a list of these values and let us clip the values if they are outside this range. So whatever values are less than 30 lower limit, 30 is the lower limit, 60 is the upper limit. Whatever is less than 30 will be raised to 30, and whatever is above 60 will be lowered to 60. As you can see, we have already seen this example. Now we need to eliminate outliers. Okay, clipping is one technique. Now you want to find the particular parameters of box plot. In box plot, what do we have? This is 50% median. This is 25% median. This is 75% median. This is the max. And this is the min. Right. So this value is Q1. This value is Q2. This value is Q3. We have seen this. So we can find Q1 by calling the quantile function on that particular column. Box plot is done for each of the columns, right? So on that column, you can call quantile function, pass 0.25, means 25%, means 50%, means 75%. And then interquartile range, that means Q3 minus Q1. Lower whisker means the minimum value you want to find out. Okay, lower whisker is actually this one, but when you say suppose lower whisker is 5, means the length of this is 5. So this particular value we are going to get. So lower whisker, or you can say minimum value, you're going to find by Q1 minus 1.5 IQR, upper whisker Q3 plus 1.5 IQR. Why we are doing Q1 minus IQR, 1.5 IQR? Because whatever value is this side is definitely lesser than this particular value, Q1. So Q1 minus something will come over here, and Q3 plus something will come over here. That is what is the upper whisker, and this is the lower whisker. Okay. And then we have found out the lower whisker, upper whisker, which is the limits. This is the minimum, and this is the maximum. That means lower limit and upper limit. Now we will call the clip function on a particular column by passing the lower limit and upper limit as lower whisker, upper whisker. And then we'll return this column. So this particular function is itself called in another function. These we have defined, user defined. So for each column in the column list, okay, for each column in the column list, where C is the particular column, okay, the name of the column name I can say. So whatever column name we have, we are passing that and the entire data frame in order to remove the outlier. So that column name is col and the data frame name is df1. So column name, pass it here. So df of that column we'll remove by clipping and return it. So for each column it will happen because for all the columns using for loop we are doing it, and then return the data frame. Okay, so this function treat outliers all is called over here. So now if we also want to plot, or you can say print the Q1 value, Q2 value, Q3 for each of the columns, you can do that. Now, after removing outliers, what will be the effect on the graph of box plot? See, previously box plot, how it was, you can see the outliers over here. This is the box plot here. It is very small because of this particular scale and such a huge value. If this is the maximum, so beyond you have a particular value, outlier. Okay. So see this particular plot. So many outliers above. All these dots, kind of circles that you can see, they are the outliers. And this is other box plot. It is small because of this particular chosen scale, and there are so many columns, right? That is why this scale has to be chosen. That is why box plot is so small, just like a line over here. Okay. So after eliminating the outliers, see the box plots are also clearly visible, and outliers, the circles above the max, below the min have also disappeared. Now here, everywhere you can see 1, 2, 3, 3 lines. That means Q1, Q2, and Q3. But here you can see only 1 and 2 lines. But note that the middle line is of green color everywhere, and here the lower line is of green color. What does this mean? It means that, see, usually this bottom line is Q1, this is Q3, and this is Q2. If the bottom line is green, that means it is Q2, and the bottom line is Q1 also, and the upper line is Q3. Means what? Q1 is equal to Q2 in this particular case. Let us check. If Q1 is equal to Q2, where we have printed the quantiles, Q1 should be same value of Q2. So it is happening in the passenger count column. So in passenger count column, this column, as you can see, Q1 is 1.0 and Q2 is 1.0 and Q3 is something 2. That means Q1 equal to Q2 has been verified by values also, and also by the plot of the box plot. Now, there may be certain incorrect coordinates also. For example, we should clear our data frame out of all the values wherein the latitude is greater than 90 or if the latitude is less than 90. Because the range of latitude is from minus 90 to 90. Range of latitude is from minus 90 to plus 90. And range of longitude is from minus 180 to plus 180. Okay. So if any value is greater than 90, means somewhere here, or less than 90, means somewhere here, then we need to drop that. Okay. So what we are doing is, incorrect coordinates will create a subset of the data set. A subset of the data set such that this subset has all incorrect coordinates. So df.lock, and if we specify such condition, using df.lock, what we can do is, we can select specific rows and specific columns. So generally, df.lock, we write whichever rows we want, comma, whichever columns we want. Okay. So columns that we want, we have to write their name. So if we don't specify which columns we want, all the columns will come. So this particular section we are not mentioning for now. That means we want all the columns, all the features. Now if we put colon over here, means all the rows. But we want the rows such that the conditions are violated of longitude, latitude. That is why using OR condition also we have separated. So this incorrect coordinates data frame we are printing. Now thankfully there are no such values which are exceeding 90 and or less than minus 90 and all. Suppose there are some values which are in this particular range, then they would have been displayed over here. Okay, at home, what you can do, you just for testing purpose, change this 90 to 30 or 20 and see if there are any values appearing here. Of course, they are valid. If there are any greater than 90, they are invalid. And thankfully, it's no such invalid. So blank, that means no rows, but all columns. See, all the columns are selected, but there are no rows for these columns because incorrect coordinates has no rows because all are correct coordinates. Now, haversine distance. This is one concept. Now, Haversine distance, it involves certain formulae and certain concepts. Let me show you over here itself. So this is the Haversine distance formula. To ARC sine, arc sine, this is called arc sine, means normally what do we do? Sine, cos, tan get applied in right angle triangles. So sine theta is hypotenuse upon opposite and so on. This is the hypotenuse. And these are the adjacent sides. So this is adjacent and this is opposite. So sine will be hypotenuse upon opposite or adjacent, whatever the formula of sine. So we are finding out sine square cos x1 y1 upon sine square and so on. Why we are using this particular formula? Because first of all, our earth is spherical in shape. It is not a plane or not a square on which we can draw right angle triangles. Whatever triangles we draw, they will have spherical surfaces. That time we need to apply this kind of sine and cos. And this particular distance that we want. In this triangle, what we'll do, triangle at its vertices, the triangle at its vertices will have the particular latitude and longitude that we want. And between this particular location and this particular location, whatever distance we have, that is called Haversine distance. And fair mainly depends on the distance. So in this way, we need to calculate Haversine distance.